Okay, so today we're gonna do gerrymandering. It's in the news. Ohio is, on our fourth or fifth drawing or something. We gave up for the moment and said we'll come back next year and try again. Okay, so I have two different samples of mathematical ways to eliminate gerrymandering. Neither one of these care what party anybody is in. All it cares about is the population of that area. So the first thing you have to understand is voting precincts. I used the Delaware-Franklin County line in the city of Howe, which is that black box, as the example. So everybody in that black box votes on city of Howe stuff. All right. However, the blue I used for the water. These people voted to use Delco water. These people use City of Columbus water. So anytime there's a water issue, they automatically have two different ballots. These guys use Liberty Township Fire Department. These guys use City of Columbus Fire Department. So if there's a fire thing on the ballot, they have different ballots. The green is the school district. This is Olentangy. This is Worthington. This is Dublin. So this little box right here votes Dublin schools, Columbus water and fire, City of Powell officials. All right. This box, everything the same except Worthington schools. So as you can see, this would be a precinct, this would be a precinct, this is a precinct. Over here, this piece, that's a precinct. All right, so each precinct's gonna have different populations. So when you're developing your voting districts, you can't look at the individual populations. You have to look at the populations of the precincts, because you can't split a precinct in half in two districts. It has to be in one. So to simplify, we're just going to say here's a state, and it's going to have 6 districts, and if we make them all even, the perimeter of each one of those districts is 4. So these are all one, sides 1, 1, 1, 1, 1. All right, and there's 6 of them. Add them all together, the perimeter total is 24. Now let's start gerrymandering. So I drew various different lengths of precincts or districts. Here are their perimeters. This one's a 2, because that's only a half size walls over there. Anyway, we got this long, like kind of almost cross-shaped thing here, and an L here, and a long skinny one here. Perimeter total comes to 30 and a half. This guy's got a C in it, almost all the way around. Lightning bolt type thing in the middle. Perimeter total of 30. This one, we got a little sliver here, which is probably, a highly densely populated city, And anyway, the shapes look much more uniform, and we're down back to our perimeter total of 24. So, Formula 1, you put in each precinct as a discrete unit of its population into the computer. You tell the computer how many evenly populated districts you want, and then you have it calculate out the map based on the least total perimeter of all of those districts. So that would be just simple, fuck your feelings kind of way. Immediately I thought of a problem of the urban districts, overpowering the rural districts. You could end up with pie-shaped districts, so it'd be radiating out from the city, so they could each have part of the city and part rural. And we do want some kind of cohesion and representation. So I came up with a second one. here's another generic state. Okay. Now, these numbers actually indicate population density. All right. Now, for simplicity's sake, they're also going to symbolize population. So there's a total of 193 population. That means I want roughly 32. If I want 6 districts, I want roughly 32 people in each. So what you do is you start with the most dense populated. So I started right here with the 10. And then you go to the next closest number. So you're always taking ones with the most similar population density. So we went up to the 8. So now we're at 18. Now we had that piece. All the way around that, the next closest ones are these 4s. So we took these 4s. Now we're at 26. All right. The next closest one, we could have taken that 5. I probably should have. I'm not a computer. Sorry. Instead, I took this 4 and the 3. And so anyway, there's one. Then, boom, I moved to this one. Right here, we got another 10. Obviously the 9, obviously the 8, obviously the 5. Boom. So where I ended up with the problem, when you get down to the last 2, or these 2 odd shaped ones here. So you start with the 7, got the 4, there's 11. Now the next one would be this one to make it 14, and then the next one would be the 3. The problem is it separates off this section and it creates an enclave that is less than our target 32. So that's against the rules. You cannot create an enclave with less than our target amount. So had to choose a different one. So had to come down to these 2s, and then etc. until it worked itself out. Now, these shapes would appear gerrymandered, but they're not, because it actually doesn't matter what party any of these people are. It's simply based on the idea that people who live in similar population densities have similar political concerns. Anyway, let me know what you think, and stay free, guys.